Absolutely.
Sir, as such, you have been so generous to accept our invitation. So we are actually we owe a deep sense of gratitude for that. From your valuable time, you spared your time for us. So it is actually very generous on your part. And we all,
Please don't be so formal. Please don't be
no,
so
sir.
formal. It is our pleasure to come here.
Thank you, sir. Thanks a lot, sir. Sir, I'll just drop a message for all the
Sure.
participants. So they'll be joining in 5 minutes and then we can start.
Not a problem.
Hope that's okay with you both.
Yeah, that's okay.
Yes, sir,
That's all
sir.
right. Yeah, in RMIT, I have a colleague, Stephen, who joined you recently from my university. You probably know him, Stephen.
Yeah, I know him because I moved to RMIT Vietnam in 2000.
Yeah, Stephen is there. One of my old student is there. Means not old student. One of my ex-student called Amit something.
Amit Jadhav.
I think so. Yes, he is a Leeds alumni. So when I was in
Yes.
Leeds, he was my MSc student, if I can remember rightly.
No, he moved to now from RMIT. He was working in RMIT after completing his PhD, and now moved to some medical field in Singapore. So now he is located in Singapore.
That is brilliant. I'm so happy to know that because I was trying to take him to the medical field at some point. So I'm happy to know that. So
And you
he
might
was,
be knowing Professor Rajiv Padhyay.
yes,
Yeah,
and there is another guy. I think I can't remember his name now. I think he is your China
Shamini, you can
collaboration.
start now. I think we'll find it over here.
Yeah. So know a few
we
people
can
out
we
there.
can discuss. We can discuss. Yeah,
Okay, sir.
Professor
Okay, sir. Can we start?
Goswami. We can discuss.
Yes,
Yes,
yes.
yes, we can.
Yes, sir.
Yep, I'm
Yes,
ready.
we can start. Ladies and gentlemen, very good afternoon to all of you. On behalf of the Technical Institute of Textile and Sciences, Bhiwani, as well as the Department of Fashion and Apparel Engineering, and on my own behalf, I would like to extend warm welcome to all of you for the final session of the AICT-sponsored E-International Conference, which is held on 18th and 19th September 2020 on recent trends in textiles. It is our proud privilege to have amongst us the stalwarts of textile and apparel sector, Dr. Parikshit Goswami and Dr. Rajkishan Nayak as keynote speakers of the session. Professor Dr. Parikshit Goswami from University of Huddersfield, UK will deliver the keynote address on innovation and trends in textiles. A very warm welcome to you, sir, for gracing the occasion and delivering the keynote address. I am sure your gracious presence and talk will certainly enrich the knowledge of the delegates and participants. Thank you, Goswami
Okay.
sir, for sparing your valuable time and gracing the occasion as keynote speaker. Professor
Thank you.
Dr. Rajkishan Nayak from RMIT University, Vietnam, will deliver his keynote address on sustainable reuse of fashion waste as flame retardant mattress filling with eco-friendly chemicals. Here I like to introduce our Nayak sir as our colleague in FE department TIT&S Bhiwani, and we are benefited by his presence during his tenure in our department.
Sir,
Who is, who is
Chatterjee, sir. Sir, I have prepared a slide for their introduction.
Okay,
So I
that
like
is
to
okay.
share that.
That is okay.
And sir,
From my side, I should say, na.
yes, sir. And sir, the first keynote address will be given by Professor Parikshit Goswami. So
Yes, yes.
after your address, I will proceed further.
Okay, okay.
Yes, sir.
So his presence in our FE department through his zeal and enthusiasm in research activities during his work besides teaching. A very welcome to Nayak sir for gracing the occasion and delivering the keynote address. I am sure your presence and presentation will certainly benefit our delegates and participants. Thank you,
Thank you,
Nayak
Chatterjee
sir.
sir. Thank you.
So we are fortunate enough to have amongst us today's session Dr. Deepthi Gupta, Professor IIT Delhi in the previous session as keynote speakers, and she delivered a burning topic in the area of future directions in textile finishing. I am sure all of us have benefited by her lucid presentation. Thank you, madam, for sparing your valuable time and gracing the occasion as keynote speakers, as well as chairing the technical session 5 of the theme of innovations and advances in fashion, garment designing, and manufacturing. We are equally fortunate to have amongst us today Dr. Binoy Midha, Professor NIT Jalandhar, for chairing the technical session 4 of theme on advances and innovation in fibers, polymers, yarns, and fabric production. Thank you, Midha sir, for sparing your valuable time and gracing the occasion. It is just to remind the delegates and participants, and as well as Dr. Nayak and Dr. Goswami, that we had experienced a lot of technical and innovative research input by our learned and distinguished keynote speakers like Dr. V.K. Kotari and Dr. Kusal Sen, eminent professor from IIT Delhi yesterday. So the topic recent trends in textiles comprises textile and clothing that is designed to deliver specific functionalities to users over and above their usual functions. Innovative clothing can be classified as protective clothing, sports clothing, medical clothing, vanity clothing, and clothing for military applications that performs multiple functions. Smart clothing items equipped with sensors and processors for monitoring of body parameters are a fast growing segment of this market. The market for innovative clothing is predicted to reach 244.6 billion US dollar by 2025. Innovative clothing is driven by developments in the field of textile materials as well as apparel production processes. Conductive textiles, composites and membranes, new fabrics, surface functionalization techniques, innovative finishes and coatings, nanotechnology are the emerging areas. CAD/CAM technologies, including those of 3D and 4D body measurement, pattern design, fit testing, mass customization, clothing comfort, clothing for special groups, and innovative fashion design are growing fields. Internet of Things, artificial intelligence, deep learning, and virtual reality tools are used in design clothing that is smart, responsive, and closer to the needs of the user. India is among the largest producers and consumers of clothing in the world. A large population and availability of raw materials is adding fuel to the production of apparel in the country. Rising aspirations of the middle class, increasing incomes, and greater awareness of market trends amongst Indian consumers is providing a strong push to the market segment. The drivers of growth are employment generation, innovation, product development, entrepreneurship, and contemporarization of traditional textile and crafts. Sustainability is an important consideration for all sectors of the textile and clothing value chain. So AICT sponsored International Conference held on 18th and 19th September on recent trends in textiles provided a platform for leading academic faculties, scientists, researchers, designers, and entrepreneurs to have in-depth exchanges on latest scientific developments, cutting-edge technologies, innovations, trends, concerns, challenges, and opportunities in the field of textile and clothing. Technological Institute of Textile and Sciences Bhiwani, the host institute, is a premier institute in India, especially in the area of textile and apparel. The Department of Fashion and Apparel Engineering at TIT&S is one of the leaders in textile and apparel education and research in the country. This conference is held under the sponsorship of AICT. Once again, on behalf of the organizing committee, I extend a warm welcome and invite all of you in the final session of International Conference on Recent Trends in Textiles RTT 2020. Thank you all, delegates, participants, and most of the things, the keynote speakers, Dr. Parikshit Goswami and Dr. Rajkishan Nayak. Thank you all.
Thank you, Chatterjee sir, for briefing the morning's deliberations and for your elaborate address. Without taking much of your time, may I now take the privilege to introduce the first keynote speaker of the day, Professor Dr. Parikshit Goswami. Professor Goswami is presently serving as a director at Technical Textile Research Center at University of Huddersfield. Professor Goswami obtained his bachelor's degree in textile technology and then worked with different industries, including a world leading third party textile testing and quality certification company. Subsequently, he did his MSc in Advanced Textile and Performance Clothing and earned his PhD degree from the University of Leeds. Professor Goswami was the head of the Department of Fashion and Textile and Associate Dean International at the University of Huddersfield. Prior to joining the university, Professor Goswami was the Director of Research and Innovation at the School of Design, the University of Leeds, and he led the Fiber and Fabric Functionalization Research Group. Since joining the University of Huddersfield, Professor Goswami has been very proactive in developing the research profile and activities in technical textiles. He is committed to multidisciplinary research and wants to build constructive collaborations between the University of Huddersfield and industries to transform the competitiveness of the European technical textile industries. Subsequent to joining Huddersfield, Professor Goswami had won government and commercial funding for several research projects, including a collaboration of $5.4 million project uh, with the University of Leeds and Royal College of Art. Professor Goswami's domain of research are product development using flexible materials and application of chemistry for functionalizing the materials. Professor Goswami manages a large profile of research concerned with fiber polymer science, nonwovens, medical textiles, implantable materials, and non-implantable materials. Not only that, he also handles sustainable materials, application and development of nano submicrofibers for novel applications, and plasma treatment for functionalizing textiles and textile chemistry. He is also a member of Society of Dyers and Colorist Education Qualifications and Accreditation Board, a trustee of STC, and a member of EDANA R&D Working Group. It's indeed a pleasure and a privilege for all of us here to have Professor Parikshit Goswami among us. So now I extend sincere invitation to Professor Goswami to take the deliberations further with his talk on the research landscape for technical textiles. Sir, please.
I have to share my presentation. I'll do it in a second.
Yes, sir. Sure, sir.
Your entire screen. No. Means I'm not very familiar with this Google Share, so I'm struggling a bit. It's not letting me.
No
I
issues,
think
sir.
you need to go for the window.
Yes, sir, sir. At the
Brilliant. Got it. Got it. Thank you. Is it there now?
Sir,
Can you
as
guys
of
see it now?
Yes, it's coming.
yes, sir.
Yes.
Yes, sir, it's coming.
Please let me know when it is there.
Yes, sir. Sir, the presentation is visible on our screens.
It is visible. Please.
Sir, you can
Should
go
I
ahead.
start?
Yes, sir. Yes, sir.
Thank you so much.
The
Thank
platform
you
is
so
all
much.
yours, sir.
Thank you. Thank you very much for inviting me for this session. Initially, the topic I was given was innovation and trends in textiles. Now, I started writing that presentation, and organically, it changed into something different. The topic has become the research landscape for technical textiles. So I'm actually happy with that, because you can't really discuss innovation and trends without discussing the research landscape. So I'll go with that. Thanks, Yamini, for the introduction. I'm head of the department for fashion and textiles. I'm also director of Technical Textiles Research Center at University of Huddersfield. At this moment, I joined Huddersfield in 2016. Before that, I was in University of Leeds for a long time, and I was director of research and innovation there. Now, today, and I really want to congratulate this team for arranging this conference, because indeed the most important thing is to understand what is the trend. In other words, for me, it is about how and what of research. What I mean by that is how relates to the methodology of research. And if you look at our academic infrastructure, undergraduate, postgraduate, PhD, everybody, the infrastructure is teaching you how to do research. In other words, what the methodology will be for research. By the time you finish your master's or we finish our PhD, we are pretty good at that. We get even better when we do our postdoc. But nevertheless, the academic infrastructure teaches you how to do research. But you know what? More and more, I realize that really the important bit is to understand what to do research on. That is where the academic leadership comes into perspective. So you need to understand, if you have a finite resource, where to allocate that resource so that you can have some impact. And your personal aspiration, the personal aspiration of a researcher, of the academic leader, so on and so forth. And if I reflect upon myself, I'm still trying to understand what to do research on. And you know what? In today's presentation, the how bit will be somewhere hidden in my talk. I'll mainly talk about what to do research on. And there is a reason for that. Means the way I want to tackle it is I have given reference to many of my research papers. People who really want to know about how, please refer to that research papers. That's there. But I'm not here to give a keynote speaking on how to analyze FTIR results. I'm not here to do that. I'm here to talk about what to do research on. That leadership, to understand which direction to go. Now, if I reflect on my research life, before probably which feels like a million years now, I started my PhD because I was absolutely fascinated with the concept of sustainability. When I heard the word, I was absolutely fascinated with it. I tried to understand more about it, the true meaning of it, not the white brush version of sustainability. And that to some extent directed my research career. I'll try to explain you why what is so important by two examples. This is one of the work I did in my team, which is about hybrid upcycled fibers. This is published in a reasonably good journal. You can go and refer to it. Why we did the research? Because somebody came to us and said polyamide 6 and thermoplastic polyurethane are used a lot in carpets. Why that is relevant? Because in UK and some other Western countries, carpets are much more common than probably in India. Why? Because in every household there will be carpets. All our houses are covered with carpets. And once the useful life of that sometimes very complex waste with polyamide 6 and polyurethane is finished, ripped off, it goes to the landfill, because infrastructure wise we still don't know very well how to recycle complex waste. However, when people came to talk with us, they said that it's not good enough if you recycle it. Commercially it's not viable, you have to upcycle it. So we did some work which is published in this paper. We measured a lot of scientific parameters and we created a hybrid fiber with a very defined porous structure. Why? Because we aspired that these fibers will be used for water filtration and other kind of application. I know for a fact that it is still being used for some applications, but nevertheless, we never patented this work. So basically what I'm trying to say, I'm trying to criticize myself that though I am absolutely proud of this scientific piece of work, it was never commercialized to an extent that I would have hoped for. Now, if you take a step back and look at another piece of research that I did, this is a patent that I got with Adidas, Germany. Now, this is about single material composites and sustainability. We did some work to produce a single material composite with polyurethane with Adidas. to produce sporting goods like sporting shoes and shin guards and whatnot. Now, this one was commercialized much quickly in working in collaboration with Adidas. Now, the point is, if I reflect on why this was commercialized quickly, but the other one is not, then the answer to that is this is more close to what the government wanted to achieve. In other words, the infrastructure was there to commercialize this application. So straight away, you can see if you want to have some impact, understanding the policy framework, the priorities of the government, the priorities of the trend, as Yamini called it, is the real important factor. Now, if we look at the trends in India, and I'm talking specifically about India because I assume the audience here is predominantly from India. This is straight from press. It is a Invest India document that was written, and it is kind of hot from the press, right? It was probably published last month, where it shows the government aspiration, Indian government aspiration towards technical textiles. Why it is important? Because Indian government is promising to put 1.4 trillion US dollars in infrastructure development for different themes like housing for all, Jal Jeevan, and stuff like that. And they are realizing, if I'm not wrong, for the very first time, that technical textiles will play a very important role in this 1.4 trillion US dollar development. Bingo, that is our opportunity because government is listening to us. But what now we have to prepare ourselves, and I'm really serious about it because this is the time we have to show what textile industry is capable of, right? So till now we are working with a simple model, and we are very good at it, where we work within the boundaries of our discipline. For textile engineers, designers, we are very good at that, right? Because it is a pretty matured subject. Now the complication comes because the government don't want us to just look into our boundaries of our discipline. They want us to work with infrastructural development. Therefore, we have to go towards multidisciplinary research. However, spoiler alert, multidisciplinary research very rarely, very rarely comes up with a tangible product with a plug in it. If you want to develop tangible products, apply for patent, have some commercial impact, you have to go towards interdisciplinary research where the boundaries of your subject area becomes porous, so you interact with other fields, and then eventually, if you seriously want to have a very good share of that 1.4 trillion pound infrastructural development, you have to think about transdisciplinary research, where the boundaries become one. You create new graduates, new PhD students who are not a replica, a mirror image of yourself. They actually know more than you. And I will try to explain how in my lecture. So, if you can start doing transdisciplinary research, you will realize the world is your oyster. You have medical, construction, horticulture, architecture. Why they are important? Because, say, horticulture, right? In 2050, the world population will be 10 billion. I think that is the prediction. Guys, we can't produce our food the way we are doing now. So we need to think about concepts like horticulture. And if you want to do horticulture, you can't work in your silo. You have to understand agriculture. You have to understand civil engineering. So it becomes interdisciplinary. Then it comes together, becoming transdisciplinary. Transdisciplinary, for me, gives the institutions, the research group, an identity, a purpose, But most importantly, it gives future leaders. Today, however, I will mainly talk about the medical side. Means if Yamini and others think that I'm good enough to talk another day, then I'll come back and talk about construction and horticultures and
Of
composites and
course, sir. Of course, sir.
thank you.
We would love to listen to you. We would love to do that for the entire of the day with your flawless presentation and such a great oration skills. So
Thank you. Thank you.
it would be an honor for us, sir.
Pleasure. So thank you, Yamini, for that. But the medical part I'm discussing today, because I was most challenged doing the medical side, and I want to take you through that journey. At the same time, it takes the most time to get commercialized, but the fruit of that exercise is the most, because I know I'm affecting people's life. Now, I have put something here like artistic outputs. Means you might think that I'm getting emotional and getting carried away with this concept, but I'm not. Because when you know how to do transdisciplinary research, you can actually even collaborate with artists. And I'm a technical textile person. If you don't believe me yet, then this is actually covered in the national press. The biggest newspaper in UK is called I can't even remember what is this paper called, Guardian. And this is my work with an artist, where there is a huge sculpture that was produced and it is presented in Yorkshire Sculpture Park, and it was covered by the UK national press. So it is possible, but we have to understand how to do that. So if I come to medical textiles, why it excites me, because the scope of medical textile is huge, and also this is the most difficult example where we have to challenge ourselves. We have to challenge our intellectual capability on a daily basis. When I go and talk with a consultant or a GP or a doctor, I'm challenged with my knowledge every day. I come back home, look at the mirror and say, though I'm a professor, I'm in education, I'm a head of the department, director of a research center, but I look at the mirror and say, Parik, you have to keep on learning. Otherwise, you are irrelevant. And that is why this subject fascinates me, and I'm going to talk about it. What is medical textiles? We are doing simple wipes. I don't have to explain you in the post-COVID situation why that is important to tackle hospital-acquired infection, as well as we are developing fabrics. I'll give you example for complex bone replacement operations. So if I want to explain medical textiles area, there are three different important parts there. One is implantable materials, tissue engineering, artificial ligaments, etc. One is non-implantable material, wound dressing, so on and so forth. And the last part is healthcare environment materials like surgical gowns, face masks, so on and so forth. Now, we are doing research in all those areas because I'm part of a fund, £9.8 million funding between 6 universities, which is called GrowMedTech. And therefore, we do research in all these areas, but I'll try to give you one example of each area so that you can understand this area slightly better. And you can understand why I'm so fascinated with this area. And I will discuss selected case studies from my research group. I will do a broad brush about the areas, but I'll give you tangible research outputs so that you can go and read those things. If you want to know how I analyze the FTIR and ATR, please go there. Here, I'm giving you the vision why I'm doing it. So just to appreciate the difficulty, if I want to develop a fabric for bone replacement, firstly, I have to understand the textile in details. I have to understand the porous structure of those fibers, the fibers itself, how the cells can migrate through that fabric structure, how the fabric structure get degraded over time, so on and so forth. But in textiles, we are good at it. We know how to do it. But the very next step is I have to, the simplest example is I have to do cell cultivation inside that fabric, and I have no idea how to do it. Therefore, I need other colleagues from Department of Biology, some surgeon, some orthopedic surgeon to collaborate with me. And I need to learn the language that they speak. So collaboration becomes key. To do that, I have to understand their language. I have to accept the fact that I don't know everything. They have to accept the fact that they don't know everything. So we have to be humble to actually be meaningful. We have to say that, guys, we have our limitations. And that is what multidisciplinary, transdisciplinary research teaches you, to be humble. So I'll give you a few case studies. First, my research background, and I have already opened my life book in front of you guys. I said that I was fascinated by sustainability. So I was doing a lot of research on cellulose, and I have many published papers on cellulose science. Then a publication came over in BBC. Now I am talking about the policy, which says wet wipes could face wipeout in plastic cleanup. So what they say is, either manufacturers, means just to put things into context, majority of wet wipes are produced from polypropylene. 99% of wet wipes are produced by polypropylene. And suddenly the government decided that, come on guys, find another alternative. And the industry was absolutely panicking at that point. So we thought that we need to do some research, because consumers going without wet wipes is not an option, because wet wipes is absolutely the first line of defense with hospital-acquired infection. What is that? You go to the hospital with a headache and get something which is much worse than that. So you have to clean the bacteria with wet wipes. So we thought we need to do something there. So this is a published paper. As you can see, there are a lot of collaborators here, and we did this work with NHS, National Healthcare Trust, England, Leeds branch. We did this work with them to understand how a cellulose wipe works in comparison with a polypropylene wipe as a factor of surface energy. We change the surface energy of the fabric using plasma treatment. And we actually looked at how gram-positive and gram-negative bacteria interacts with different fibers as a factor of surface energy of those fabrics, which we manipulated. I'm repeating myself, using plasma. I know how to do it. I have no clue to understand critically this interaction between the bacteria and those fibers. So my colleagues came in, there are healthcare professionals, clinical people came in, and we produced something which, in my opinion, meaningful. Still, it is not commercialized because this is fundamental knowledge. So we expanded it. We did more work with that. Say, for example, this is one factor, factors affecting removal of bacteria as a factor of dynamic wiping. Then we publish some more papers which might appear not relevant. For example, this is a paper published in Applied Polymer Science, where we manipulated the structure of the fibers itself based on the input knowledge that we had. And we created much complex fiber structures. Nevertheless, they are produced very cheaply, or possible to produce at a cost point which is relevant to wipes. And now we are moving towards commercialization, not for one project, but for many projects. But we have to create that foundation so that we can go to that commercialization. And it happened for many years. Now, straight from wipe, and you know what? The knowledge we learned from here it's absolutely paramount to us now to develop new generation face mask and other PPE equipments. Why? Because if somebody knows about the PPE area, they will know that there are two standards, EN 149 and EN 14683 for face mask. Both depends on melt-blown polypropylene, and those polypropylene masks produce in billions and trillions, which will end up in your oceans eventually. Guys, we can't let it happen. So we need to develop face mask with cellulosic biodegradable material. That doesn't mean that you have to just do this kind of research. That means you have to influence the policy. You have to create new standards for face mask. And we can't do it till we know this knowledge. And that is what is the innovation life cycle. I'm moving that from a clinical need where we did research. Ostomy pouch, what is that? 120,000 people in UK alone live with a phenomena called stoma, which is created because of bowel cancer. In Europe alone, there are 333 stoma patients. Every year, 1.23 million new cases of bowel cancer are recognized, identified. Now, the point is, so what? Now, people who have bowel cancer, their large intestine is taken out of their stomach, and the human waste can come out at any time into those bags that you can see. What patients do with that? They have to take the bag out, put it in a plastic thing, and put it in your normal bin. What is the problem with that? Firstly, financially, NHS spends 630 million pounds every day, that is the health provider in UK, to tackling for stoma appliances, incontinence pads, dressing, etc. It's a growing problem because people are living longer and so on and so forth. The problem is we are all used to a toilet culture. We go there in the morning and stuff like that. These patients, poor guys, and I have talked with 630 of them. Some are kids, right? Some are 10 years old. They come to me and say that I can't go to school because people bully me because my poo comes out at any time. And it breaks your heart to see that kids have to live through that. The solution and the bigger picture there is 36.5 million pounds stoma pouches with human waste end up in our landfill. In India, the scale of this problem I can only imagine. There are things in that so-called human waste. There are hepatitis A, B, C, which stays there for 10 years, contaminating our water, contaminating everything. So when we collaborated with a company, they said that, Professor Goswami, if you can develop something, a fabric which is hydrophobic, but disperses in water, then the patients can that flush it out. Now, for a non-textile person, they will say, yeah, it sounds simple. But for a textile person, you can imagine how difficult it is to develop a hydrophobic material which disperses in water. So we did this. As you can see, the material is totally hydrophobic. It is so hydrophobic and mechanically strong that it can hold your human waste, including the urine. But when you give a predetermined amount of mechanical action into that fabric, it disperses into single fibers. What that means is that human waste along with the fabric can be flushed down. Simple, but think about the impact. There are millions and millions of people now who don't have to be conscious about their social presence. They can continue with their normal life. A simple invention leading to changing life of thousands. You know what? We'll commercialize it. We'll give the life back to those people. Another problem, which is very close to me, is chronic kidney disease. What is that? If you have a kidney problem, a chronic kidney disease, you go through a system called hemodialysis, artificial removal of toxins from your blood so that kidney don't need to do it. We go through a system where we purify our blood, which kidney normally does. Brilliant. What is the problem? The problem is there are 150 kinds of known toxins. Some are water soluble, which the dialysis machine brilliantly removes. There are some middle molecular weight molecules. The dialysis system don't really remove that very well. But there are protein-bound macromolecules, which the dialysis system don't remove at all. They build up in your body, and that gives you cardiovascular disease. Therefore, at this moment, there is really no treatment for chronic kidney disease. So people who have chronic kidney disease, either they have to do a kidney transplant, or they are at a very bad stage in their life where there is no way you can remove the protein-bound macromolecules from your body. So what we did, we developed some filters which can specifically target the most horrible toxins in that bloodstream, using textile filters and some biological additives into them, which can target those macromolecules, which can remove those toxins from blood using textiles, using surgeons from NHS hospitals, and using biologists. Now we are going through a clinical stage with this product. And you know what? I dream that one day there will be some kind of treatment associated with chronic kidney disease based on this work that we are doing, where kidney transplant won't be required. And I wish I have started before, because then my grandmother will be still alive. And that is the kind of impact we are talking about when we can go to that transdisciplinary boundary. There are other real problematic areas like antimicrobial agents and wound dressing. This is one of our published paper in that domain, where we have taken a compound called methyl glyoxal, which actually comes from manuka honey. We put it into different fibers, did all sorts of clinical research that we need to do. We also use manuka honey in different nonwoven fabrics. But when we came to commercialization, we realized that the problem is not really only with the biodegradation of the antibacterial agent, but it's about the conformability of that fabric around different wounds. So the normal kind of measurement techniques like bending rigidity and stuff don't really work that well in a clinical environment. So we published a paper with an American university where we very critically, with applied mathematicians, wanted to understand how we can define the conformability of fabrics. Now that paper is also published, and you can go and have a look. So as you can see, if you want to really make an impact, you have to understand where the problem lies. Sometimes it's not as simple as creating an new antimicrobial agent. It might be much fundamental than that. It's to understand how that dressing fits around a wound, as simple as that, and then developing tools to help that. Now, for this research, we knew that it's no point commercializing it, and we knew that the textile community needs to hear about it as soon as possible. So we published it in Textile Research Journal. But if you go and look into this paper, you will realize it's a paper on absolutely applied mathematics with a huge impact in wound dressing, which is a biology subject area. Transdisciplinarity. Sorry, I'm going on about the same thing, but I will. That's the topic of this presentation. Now I'm going to slightly hard research area where we are developing hard tissue repair material with textiles. Again, the paper is published where we took a FDA approved polymer and incorporated a patented technology from Leeds University, self-assembly peptides, into a polymer structure. And we created an architecture where if you look at the fibers, you will see there are submicron as well as nanofibers into the same matrix. Why? Because the nanofibers in a tissue environment will degrade first. The bigger fibers will give the structural integrity, and eventually all of them will degrade. And this will be used for hard tissue repair. And it is a published paper. There are follow-on papers from here where we are actually doing some preclinical trials. However, then we moved the subject where we can even put API, active pharmaceutical ingredient, therapeutics into the fabric. And then we measured the release kinetics of those active pharmaceutical ingredients from the fabric. And now we are in a stage where we can start thinking about commercialization. In fact, we have started different patenting process around in or around this subject area. So watch out for the space in this area. Now, also what I realized that if you really concentrate on textiles and follow the policy procedure, you can come up with material that you have no idea how they will be used, cross-fertilize other disciplines. For example, I'll go through it very quickly, but you all know that in textiles, there was a point before a few years when fluorochemistry was banned and the industry starts panicking. So we developed a material, and I'll give you a video for that, and I'll explain it later. We developed a stretchable and breathable membrane without fluorochemicals for outdoor garment. So you can see this fabric, which is made out of nanofibers, are completely stretchable. Means I must say I really like visual representation. So I'm trying to visually say here that the fabric is hydrophobic because no water is coming here, and it is breathable. Because you can see the air bubbles are going through it. For more scientific audience, if you are interested in knowing the scientific facts, then I'll refer you to my patent in a bit about this technology. But this fabric, the science is very simple. The science is the pore size of the material is designed in a way that it is bigger than air bubbles and it is smaller than water droplets, right? It's as simple as that. But we made the technology complicated by putting different nano particles inside it in a way that it actually creates very nice frictional resistance with your skin. We now, for the scientific audience, we actually did some tests and we proved that our technology is actually much better than the industrial standard without using fluorochemistry. We did all sorts of antimicrobial measurements and stuff like that, and then we patented it, and this was nominated for the best textile innovation in 2017. Brilliant. We can commercialize it, but the biggest application of this fabric will be in the face mask industry. I never imagined when I started developing this product. So we can cross-fertilize different areas. And now I'm taking this technology even step further with using different kinds of nano material to incorporate within that fabric structure. And to make it more complicated and working with some other industries, we are actually developing some hybrid nanoparticles, but that talk is for another day. Also, what we did is we tried to reach out to consumers to understand very critically what the problem really is. So we published this paper in quite a good journal, and we tried to understand what the consumer really wants from their outdoor garment, and we designed it with a company according to that. So what is the future? What is the trend? We have to stratify, personalized the medical industry. What I mean by that is, I'll talk about me and my sister, right? I'm very fat and ugly, and my sister is very thin and beautiful, right? But when we go to the doctors with
Sir,
a headache,
I need to, sir, I need to interrupt here. Beauty lies in
yeah.
the eyes of the beholder, so you can't really say this.
Okay, I'll change it. I'm still fat, but I'm not very ugly. But my sister is very beautiful and
That's
much
better now,
thinner
sir.
than.
That's much better
Thank
now.
you, thank you. But when we go to the doctor, they give both of us the same medicine, 500 milligram aspirin or something like that. For me, it is useless because I'm getting less amount of drug. And for my sister, it is toxic because she's getting more drug than she needs. Now I'll give you the simple example. We are developing transdermal drug delivery system with fabrics where you can easily cut it according to your BMI and put it in your arm. That is the simplest example. There are more complex examples that I don't want to talk about today with say orthopedic patients we are working with, where we have to make medical care personalized, and textiles will play the biggest role there going forward. And that is the trend we have to follow. And I can't do it alone. So this is a cross section of the senior members of my team. And if you look here, the guy standing just behind me is actually a cancer drug developer. So he is a postdoc working with me whose PhD was in developing cancer drugs. There are other people here. The lady standing next to me on my left, she comes from the civic society. She worked with the government for her whole life, and she is part of our team now because we want to understand how we can influence policy. And you know what? If you want to make a difference, as a strategic leader, you have to create that ecosystem. And then you have to help the industry to work with you. I'll give you one example. I've already discussed about another one. This is a project between University of Huddersfield, led by me, in University of Leeds, led by Professor Russell, and Royal College of Art, led by Susan. We came together and we got a funding of 1.4 million pound. Now we are working with 260 companies, and you'll be surprised if you know names of those companies: IBM, Marks and Spencers, Burberry, Make It British. Uh, eh, Half of the companies, and this project is called Future Fashion Factory, and the biggest stakeholder there is IBM. And we are bringing those people together so that we can meaningfully create IP out of that, those projects, and then we can license it to different companies. And once we do it, the government has started taking us seriously because we are affecting the GDP of the country. And that is what our aspirations should be. With that, I'll end, but I just wanted to give you a picture of my office and my research labs where it is situated. So this is a building called Barbara Hebdot building, and my lab is somewhere here. Guys, thank you so much for listening. I really appreciate it. Thank you.
Thank you, sir. Thanks a lot. It was in fact privilege for all of us to listen to such amazing, and I was
Thank you.
completely spellbound. And heard you for the first time, but I was actually impressed at the very first instance when I had first witnessed your talk in IIT Delhi. And
Thank you.
and today also I was equally impressed, and it was such a brilliant presentation with visual effects and all. So I owe you a deep sense of gratitude for accepting our invitation, sir. So thank you for this impressive and flawless talk, and above all, sparing time for us from your preoccupancies. Thank you. Thanks a lot, sir.
Thank you very
So
much.
so
Pleasure.
sir will be very much with us during the valedictory session also, where he'll be talking more about the current scenario. So for the time being, we have the next speaker with us. May I now extend gratitude invitation to second keynote speaker of the day, Dr. Raj Kishore Nayak. Dr. Raj Kishore Nayak is presently handling the profile of senior lecturer at School of Communication and Design, Remit University, Vietnam. So may I now share his brief profile, please? So I'm sorry to all the keynote speakers, Professor Parikshit Goswami and Professor Nayak. I have to make your profile brief because if I start reading the entire profile, it will take the entire day. You have so many feathers to your crown. So I have to make it brief. Sorry for that.
That's okay, ma'am. Thank you.
So, Dr. Raj Kishore Nayak, he is working as senior lecturer with the School of Communication and Design at Remit University, Vietnam. He completed a PhD from the School of Fashion and Textile, Remit University, Australia. He worked with the School of Fashion and Textiles, Remit University, Australia from 2013 to 2016 in teaching and research. He also served as a product development engineer at Bruck Textiles Australia from 2012 to 13, Dr. Nayak. And now I would like to emphasize on this line, and I would proudly like to say this, that he had worked as senior lecturer in TIT&S Bhiwani, Fashion and Textiles, our very own department in India from August 2004 to 2008, and as project associate at IIT New Delhi from March 2002 to August 2004. Sir, you are also an inspiration for all our passed out students and present students, that how with our determination and hard work we can achieve the great heights in our life. His teaching interest includes sustainable fashion and textiles, circular economy in fashion, advanced manufacturing technology in fashion and textile, and research interest includes circular economy, sustainable fashion and textile, human ecology, advanced materials in fashion and textiles. He has more than 18 years of experience in teaching and research related to fashion and textiles. He has published about 120 peer-reviewed papers in national and international journals and 11 books in fashion and textiles. Dr. Nayak has been conferred with several prestigious awards like Remit Excellence Award for Learning and Teaching in 2019, Remit University Team Award for Research Excellence in 2015, Remit Research and Teaching Award in 2012, and Remit University International Scholarship in 2008. Dr. Nayak completed his bachelor's in textile technology from ITT Chaudhar, India in 1999, and master's in fashion and textiles from TIT&S Bhiwani, India in 2001. He has witnessed a long and successful professional journey in academics, research, and industry. Dr. Nayak has also been prime investigator in several research projects like Remit University funded projects on flame retardant textiles, stab and spike protection projects from DMTC Australia, firefighters protective clothing, and many more to his credit. So may I now may I now request Professor Dr. Nayak to proceed with the deliberations, and he will be the
Uh,
next one who will be talking on sustainable reuse of fashion waste as flame retardant mattress filling with eco-friendly chemicals. Sir, may I now
Thanks,
request you?
Damini.
Thank you, sir.
Thanks, Jamini ma'am. Yeah, let
The
me upload this PowerPoint. Is it visible now? I already shared.
Sir, it is not visible as of now.
Okay, just 1 minute.
Yes, sir. Sir, we do have your presentation in case of any need.
Uh, okay, ma'am, you can upload from there. There is some problem to upload. I don't know why it is not uploading.
Okay, sir. So I'll request the technical team to please start sharing the screen and present Professor Nayak's presentation. Are you there?
Gurpratap Bhaika, Gurpratap Asif.
Yes, sir. Very soon we will be presenting the sir's
Sir,
presentation.
yes, we are
Just 10
presenting,
seconds,
sir.
sir.
Just
Is
give us
somebody
a while.
uploading?
Sir, I think the PPT should be visible.
Yes, it is visible now.
Okay.
Okay, but the screen size is very small. Can you please maximize? Okay, I think that should be okay. Thanks, Jamini madam. Thanks, Chatterjee sir, for your brief introduction. So, as you said, before going into my presentation, I just want to mention in a brief how the things are different when I joined in RMIT in 2008. I started my Doctor of Philosophy on the 8th of August 2008. So that was really memorable. 888. Everything was 888. 8th of August 2008. So when I joined in the first day, my supervisor told that think about impact. As Professor Goswami has told now, creating the impact in the community. That is the first thing when I joined, I learned from my supervisor. So, what is the meaning of creating impact? We don't think about just doing research and then publishing. Can you please just, okay, that's okay. So, uh, not just like doing research and doing some publications. They wanted to see the commercial applications of this product. Therefore, my supervisor told, take a subject, select a topic which is going to be useful for the society. There is a scope to produce high quality research papers or even patents. So what I proposed in the beginning was thermal comfort properties of fabrics, because I was working in TIT Bhiwani, and my research area at that time was thermal comfort properties. So I selected that area. And when I went there, I got these comments from my supervisors. The topic that I am going to do my PhD is not going to create enough impact. So I have to change to a new topic on nanofibers. This is the one thing. The second thing is facilities. So when I joined to do my research in nanofibers, many things were so new to me. Like they have got all the facilities, but my knowledge is just limited. I just know how to operate the tensile testing machine or the Beasley balance, some of them measuring the hydrophobicity, hydrophilicity. But there are so many other machines, other facilities I don't understand. Then the term cross-disciplinary research or multidisciplinary research comes into action. And the people, so much of expertise are there, you will be not feeling that you don't have sufficient knowledge. The knowledge comes from the surroundings. You see people doing very sophisticated research. So that will inspire you to do research to create impact. So when I joined, so I had like a group of multidisciplinary research team. It's not only textile and fashion, they were from all different fields like earth science. So when I went to measure the uh, conductivity of polymers, I have to go to the science department because the conductivity of polypropylene was so low, which is similar to the soil. Then I have to go electrical engineering department. I have to go to the cell growth department. I have to go to the antibacterial properties measurement department, that is the biotechnology department. Then I have to also go for different work for the technical textile test. You have to do bullet testing. I have to approach these people who can test the protective clothing with firing the bullet or stabbing the mannequins in the real testing conditions. Facilities, enormous facilities. Every time you go, all the things will be ready for you for testing. And online booking system. You can work from 7 o'clock in the morning till 9 or 10 p.m. Online systems are so well managed, no need to ask for anything. You got the training, you go and get whatever you need, and you are ready to go. Nobody is there to interfere you during the testing, so you are independent during the testing. Yeah, these are the few things that creates the difference between doing the research when I was in India and doing the research when I moved to Melbourne. The main thing is facilities and multidisciplinary research. So this research that I am going to talk today is the research that created an impact in terms of commercialization in Melbourne. So this project was the first project. I got a grant of 30,000 Australian dollar under my leadership. So this project came to me. I applied for this, and I was leading the technical team in this project. So I'll briefly mention about this project. There is a mattress manufacturing company called TIT&S in Australia. So they manufacture mattress, pillows, beddings for Australian consumers, and many products for these mattress manufacturing they get it from China. So there are two things. First thing is the time it takes to get the product from China, and second, the total cost of the garment. Sorry, total cost of the final product was really high. And when they get all the product from China, it takes a long time. Sometimes when they need it, they don't get it. So in the mattress, there are 5 different layers. So one layer, they use flame retardant textiles. I think we need to go to the picture slide. Okay, this I'll come here. Okay, let me explain, and then I should start from the beginning. Madam, how much time I have got? Accordingly, I can plan. Gemini, madam.
Yes, sir. Yes, sir. Sir,
So,
actually, it was in full screen sharing mode, so I had to mute my mic. Sir, the time is on your side. Sir, you can continue with your work. No issue, sir.
okay,
You
so
can go
because I
ahead. You
planned
can
for.
go ahead.
Yes, sir.
Okay, all right.
Sir,
So
sir, you please keep on telling me that which slide has to be shared. I think I am
Okay.
mismatching somewhat. Yes, sir.
All right,
Please
that's
do
okay.
that.
That's okay. Yeah.
Okay.
So yeah, please don't move. So when I say, then you can keep on moving.
Okay. So on which slide should I keep it now?
Okay, so just keep it here
Okay. Okay.
at this slide. Yeah, let me summarize this project, and then I can come back to the slides.
Okay, sir.
So yeah, that Australian mattress manufacturing company, they use a filling layer of 100% polyester, which is flame retardant, and they get it from China. So getting from China, it takes sometimes long time, and they have to bring it and store it. So what they wanted is they wanted to replace this polyester layer with the waste fibrous layer. So basically, this layer, polyester layer, what it does is it just creates a gap between the spring layers and the next layer, which is made up of polyurethane, and there is no other function. So they thought of using the waste material derived from the consumer waste collected in Australia. So in Australia, lots of people donate their clothes when it comes to the end of life. There is no scarcity of this used material for recycling. And when they came for the first meeting, they told, we want flame retardancy of these fibers derived from the Australian consumer waste. We don't want anything else. We want the flame retardancy. That's it. And it should be economic and it should be eco-friendly. So when we consider sustainability, eco-friendly is the most important thing. We were told again and again, the chemicals you will be using for flame retardancy need to be eco-friendly. Then we started this project. The company approved $30,000. So I was very happy to have this $30,000 project in my name for the first time. So getting the first project, doing everything, it was so much of encouraging to me. And then I started working. Okay, so can I just go to number 3 slide, please? Number 3.
जमीनी नंबर 3 स्लाइड में जाओ.
It's number 6.
Number
3 slides
3
before.
slide.
Number 3. I think again this is number 6. I cannot control this. Is there any difficulty in loading the slides? Uh, okay, I think I start from here. Yes, you can. Okay, it's changing now. Okay, number 3 slide now. Okay, so I'll just give the introduction of the problem of the waste in the developed countries and developing countries. So when we talk of the waste problem in all the developed countries, thanks, madam. It is now visible. So we did the background research of the problems in using the waste into the product, and as such, the problem of the waste in Australia. So there are lots of waste. In 2016, about I think 2017, a total of 0.5 million tons of waste was collected from the consumers in fashion and textiles. Such a huge amount of waste, which is a major problem in the UK, in the US. Many of the consumers, they just use the garment just once and throw them into the landfill. So this is becoming a trend. This is a trend in because of the fast fashion brands such as Zara and H&M. They are producing so many designs in very cheap prices,
अच्छा ठीक है ठीक है ठीक है
with very cheap prices every year. So like every 4 to 5 months or 5 weeks, we get a new product coming into the market. And the rich consumers, they change their style every they go and buy. It can be to show up or it can be an impact buy. So what happens is there are lots of rejected clothes ending into the landfill. So we did this research and we found what will be the problem of managing the waste for the company. So we have to do a background research for the company to state what is the current scenario of the waste, whether the company is going to collect enough waste for their manufacturing plant. So this is just a background of this project. Can you please move to the next slide? Yeah. So coming to the amount of waste, if you consider only in the UK, about 1.8 million tons of fashion waste was collected in 2016. So similar quantities of waste is generated in US. In Australia also, consumers throw a lots of clothes which can be reused or recycled. But many people, like when we uh, we come to the end of life of some clothing in the house, it can be the home textiles or it can be the garments that we use. We just don't throw into the landfill because we are afraid of this $250 fine that we need to pay if they check that we are throwing the clothes into the rubbish bin. So therefore, we arrange a pick-off from home. We call the council and they can come, they can collect these waste and recycle. Or sometimes we can take into the recycling center and give them for recycling. So these are some of the opportunities that we lack in developing countries. Like my experience in India, or now I am in Vietnam. So there are not many organizations which work with this kind of rules and regulations are very strict. Therefore, people throw these end-of-life clothing into the landfill. And the problem is, can you please move to the next slide? I think I covered this one. The next one, please. Yeah, okay, again. Okay, the problem is the greenhouse gas generation. So the clothes going into the landfill, they produce carbon dioxide, methane, or oxides of sulfur that creates air pollution. The chemicals, the dyes and pigments used in the textiles can leach into the ground, intoxicating the soil. So therefore, recycling, reducing, reusing these end-of-life clothing or following the circular economy concept is the solution. So we adopted circular economy concept for this project to reuse the consumer waste. Yeah, next slide, please. Yeah, I think I already mentioned about this. Yeah, one more. Yeah, so there are okay, maybe I move directly to the project because I already discussed about all these backgrounds. So one slide before is, yeah, project background. So this project was funded by Tontine Group in Australia. So Tontine is the largest manufacturer of mattress and bedding material in three places in Australia. So their main factory was located in Melbourne. That was very close to RMIT Melbourne campus. So for this project, what we did is we collected the waste by keeping the donation box in front of the company. When they gave this project to us, we just told the company to set these boxes to collect consumer waste. So in 3-4 weeks, we have got so much of consumer donations directly coming into the boxes. We took these waste and started our experimental work. So can you please move to the next slide? And our objective was to get flame retardancy to the fibers derived from these waste. So we have to follow Australian standard and New Zealand standard 4220/1994. And the standard says all the components used in the mattress should be flame retardant. But if you consider the fibers that we extract from these waste, consumer waste, they are highly flammable. So we have to apply sustainable and eco-friendly chemical to make it flame retardant. In addition to making flame retardant, we have to also test, we have to characterize other properties are not impacted. So we did several characterizations. I'll describe about these characterizations. Can you please move to the next slide? Yes. So the characterization process. Okay, so I just missed something. I need to tell. So when we collect this consumer waste, we are not allowed to directly use these waste because we do not know the history of this textile material. So as for the OHS, which is occupational health and safety, we need to disinfect this product, make it bacterial free. So for making it bacterial free, we wash this product in the laboratory conditions at very high temperature using the industrial machine at RMIT. We got an industrial machine to process large quantities of garments, fabric, whatever comes for testing. So we disinfected these raw materials, the textile waste product, and then we separated the trims like G4, button, and then we set it into smaller fibers. And these fibers we use for our experimentation. So we got about 30 kilograms of total wastage from the company to process and characterize. So different characterizations such as, can you please move to the next slide? Yeah, I think I described about these slides. Yeah. Yeah, so characterization, we did the burning test. So in the beginning, we have to do the burning test. Basically, take the textile fibers derived from the consumer waste and burn it and feel the smell, identify what may be the components. So from the burning test, like for example, the cotton fiber, we just smell if it is burning like a paper, then we assume that it's some cotton or it can be a viscose. Similarly, we did the burning test for all the fabric that we collected, different lot, and then we knew approximate composition of this blend. And then we did the quantitative blend analysis. Although we have these NIR facilities to do this blend analysis without any chemicals, but I prefer to do to get a better result. And listen to me when I moved from TIT, because I worked in similar project to identify the blends. So that was very helpful to do the blend analysis. 5% sulfuric acid, for wool 5% sodium hypochlorite, and so on for different types of fibers. After the blend analysis, we came to the conclusion that cotton is the predominant material used in the consumer waste of Australian consumers. So you can see here, there were two samples for this blend analysis. The first sample produced 50.2 percentage cotton, and 52 second sample produced 52.1 percentage cotton. So we can conclude that cotton is more than 50% in Australian consumers' garments. So I think this is a global trend. Cotton is the predominant fiber in the fashion and textile industries. Then the next predominant blend was polyester, which was like the normal global trend. The polyester is the second predominating fiber in the fashion and textile industries. We found some amount of viscose, which was not present in the first blend, and it was 0.5 percentage in the second. Nylon 2.1 percentage, 1.8 percentage in the first and the second blend respectively. Acrylic 4.8, 3.8, and some other fibers. Can you please move to the next slide? Okay, so after the blend analysis, then we knew that what is the composition, and we did some trial with the commercial flame retardant finishes to see how these blends will be behaving before we select our chemicals. Sorry. So we selected two commercial chemicals, which is given in the bottom of this table. Flame. The composition of this chemical is not known, and this was supplied by the commercial supplier of RMIT, and they did not say anything about the composition of this chemical. The other composition was a combination of phosphorus and silicon compound. So APS stands for amino polytriethoxysilane, and the other compound was H3PO4, which is known as diguA-HP, diguanide hydrogen phosphate. So these are two commercial products that we used in the beginning. Then we went into selecting the chemicals. And from the background research, I came that ammonium phosphate and citric acid are a good source, which are eco-friendly, and they don't need EPA certification. EPA is Environmental Protection Agency. So any toxic chemicals, if we use, we need the certificate from the EPA in Australia. And the company did not want any certification of these chemicals. And we analyzed from the EPA that we don't need any certification for these two compounds. Of course, we selected a binder and wetting agent. And many of the chemicals you can see was used at 5%. The main components were citric acid and ammonium phosphate, which was used in the 5% wet by wet basis, and wetting agent was used 3% volume by volume basis. Can you please move to the next slide? No, it's too much. The previous one. You move 2 slides. Yeah. Okay. After selecting these chemicals, 1 slide ahead, please. Next slide. Yeah. After selecting these chemicals, we prepare this in the laboratory method. distilled water. We took the distilled water in the required quantity, and then we mix the wetting agent, and we weigh the citric acid and the phosphate in a separate beaker. So once the distilled water with the wetting agent was ready, and then we mix the phosphate in the beginning, and then we mix the citric acid to have a clear solution, and then we spread these chemicals with 100% intake by spraying. So the other commercial compounds, we have to dip the fibers into the chemicals, because this is a ready-made chemical, and they use by dipping the fabric. That chemical was for fabric. We have to develop for fiber. So we did as per the direction of the company to treat our fibers by dipping into the commercial chemicals. But in our case, we have to spray with 100% add-on. And after spraying, we left the treated fiber for 1 hour, and then we dried in a hot air oven at 110 degrees centigrade. And then we did some characterization. Can you please move to the next slide? We measured the burning behavior. Normally for fabrics, we do the inclined burning test, but we cannot do for the fibers. And with the discussion with the company, they wanted their objective, because there were not many technical sound people. They wanted the fiber to be flame retardant. So we told them, by testing the limiting oxygen index, which is known as LOI, we can do this flame retardancy testing. So we did this test as per the ASTM D286317A. So LOI basically indicates the amount of oxygen in the air we need for sustaining the burning, and that will create the complete burn of the fabric or any textile material. So basically, we measure what percentage of oxygen we need to burn the specific material. Normal textiles, which is not treated with flame retardancy, will burn much lower than the 20 percentage content of oxygen in the air. We know that in the air we have got about 20 percentage of oxygen. For example, cotton fiber will burn less than 20 percentage of oxygen in the air. 19 point something is the LOI of oxygen. Our objective is to increase the oxygen requirement more than 26 percentage. That means we need a 26 percentage oxygen in the air to ignite the material and sustain the burning, which is highly unlikely. We cannot get 26 percentage oxygen in the air. So therefore, it is very hard to start the ignition process and sustain the burning. And furthermore, we did another electrical burning test to again confirm in two different standards. So in electrical burning test, we give a rating. Sorry, I just got a cold because of too much of air conditioning in RMIT. Okay, so the other test was electrical burning test, which is based on testing the 5 millimeter of the material with wool. We see how much wool fiber is burned when we put a flame, a butane flame from the bottom, and there is a layer of the textile material or the fiber material that we are going to test between the wool and the flame. So we see the amount of damage to the wool. If the fiber layer is flame retardant, then there will be the minimum damage to the wool fiber. And the rating is from M1 to M4. The M1 indicates very good result, means it is completely flame retardant, whereas M4 is completely burning, the material is completely flammable. Can you please move to the next one? Then we did the thermogravimetric analysis to see that our chemical treatment has not done any changes to the thermal properties, or to check the thermal stability of these treated fibers from the consumer waste. So for doing TGA, which is thermogravimetric analysis, we use Perkin-Elmer Pyrrhus 1 TGA. So we take 5 milligrams of the sample in an aluminum crucible, and then we subject to heating at a constant rate from room temperature to 850 degrees centigrade under nitrogen pods of 10 milliliter per minute. And then we represent this wet loss as a function of temperature. Can you please move to the next slide? Then the other part was to check whether there is any change in the chemical composition by treating with these flame retardant chemicals. So we did that by FTIR, which is Fourier transform infrared. We use the Perkin-Elmer spectrum 400 spectrometer, and the number of scans per sample was 8, and the wave number, which is the reciprocal of wavelength, we used the wave number of 4000 to 650 centimeter inverse. So the spectra that we receive from FTIR can give the indication of what type of material or what type of chemicals are present in terms of observance. So when I go to the details of the discussion, I can show you there. The next slide, please. X-ray diffraction to know the crystalline properties of the fibrous waste. Is there any change in the crystallinity or the structure of this cellulosic component, because cellulose was the main component? So we used advanced diffractometer by Bruker D8 with copper K alpha radiation at 40 kilovolt and 40 milliampere. Lynx eye silicon stripe detector was used to get this XRD pattern that I'm going to discuss, and we use a 2 theta range of 5 degrees to 90 degrees. The step size was 0.0 degree, and we counted at 0.5 seconds for each step. And the main thing was getting the XRD graph from the EVATM, and the EVATM will suggest what can be the chemicals. It's sort of getting everything that we want instead of going into the literature. So we got all the result from the EVATM, which is really good. Many industries or even academic institutes, they don't have this EVATM, which will be facilitating identifying the chemicals. So we had this equipment with EVATM. Okay, the next slide, please. Okay, now coming to the results and discussion. So as I mentioned, we tested the waste fiber, which was untreated, and found the limiting oxygen index, or LOI, was 19.1. Then we tested all these 3 different finishes, including our ammonium phosphate and 2 commercial products. So we found that the LOI of our flame retardant, which is ammonium phosphate and citric acid, is 26.5%. The LOI of Citaflame was 27.4, and the APS and S3PO4 was 28.8. So what we wanted was the minimum of 26 LOI, which we exceeded. We could have got more by applying more of these. As I said, we used 5% because the company wanted to have minimum cost. So 26.5, they were happy. we did not went high because that increased the cost of this waste. So they did not want more than 5%. If we treat more, we will get higher LOI. But the company was happy to have this 26.5. And then I have got this data for comparing different textile material and our treated chemicals, chemical treated textile waste. So you can see cotton fiber has got 18.4, which is less than 20%. That is the composition of air, the oxygen percentage in the air. Polyester nylon got 20 to 21%, and acrylic got 18.2% LOI. So we are well as per the requirement of the company. We achieved their target in the flame deterrency. And the next result will be on the electrical burning test. Can you please move to the next slide? Yes. Now coming to the burning test in the electrical burner. So we got a rating of M2, and you can see two other commercial products giving a rating of M2 and M1. And M2 is okay. So it takes about 20 to 25 seconds to start the ignition process. And the company was happy to go with the M2 result. So we achieved the flame deterrency in terms of LOI and the electrical burner test. Then coming to the next result, in the next slide, please. Yeah, coming to the thermogravimetric analysis. So we compared between the samples that were treated with flame retardancy and the untreated samples. We found that both the samples started losing their mass. You can see here. I don't know if there's a scope to mark here. I cannot see any marker in the presentation. Anyway, so I'm just pointing here. So 220 degrees centigrade, both of them they started losing substantial amount. You can see the one the top, that is the finished textile. Here also this is the finished textile, and this one, the blue one, is the untreated fibers waste. So both of them they started losing their mass. It was about 2.2% for the treated fibers and 5% for untreated fibers at 220 degrees centigrade. When they reach about 300 degrees centigrade, they rapidly lose their weight and then they degrade. So we run this experiment up to 850 degrees centigrade. In the end, you can see about 2%, 2 to 3% of residual weight is there, which is because the carbon content in both these materials, treated and untreated. So what we found from the TGA results, that the treatment of the flame retardancy increased the thermal stability as indicated by the curve or the higher degradation temperature of the treated fibrous waste. Next slide, please. Coming to the FTIR. So as I said, we plotted the wave number versus the transmittance or the observance. You can see here the peaks are very similar in the treated sample, which is the bottom one, and the untreated sample, the top one. So the similar peaks in both these treated and untreated samples indicate that there is no chemical change to the fibrous waste. When I did my work in the nanomaterial, I found there were some chemical changes because I use different additives. So I get different peaks which is not present in the original sample. But in this case, there were no chemical changes. And we concluded that the treatment of these FR finishes is just hold on the surface by the binder. There is no chemical reaction or no chemical change between the fiber and the FR finishes. Yeah, there are some peaks that we, can you please move to the next one? We found some peaks corresponding to cotton, corresponding to polyester and citric acid, as indicated by the peaks. For example, 1092 and 1240 was corresponding to the OH group and carbon-carbon group in the cotton. Similarly, 1012 and 1410 was corresponding to carbon, oxygen, carbon, and carbon-hydrogen bonding in polyester. And 2920 and 1350 was corresponding to carbon hydrogen stretching vibrations in citric acid. So we confirmed that these materials are not changed because of these chemical reactions. We did not see the peak which is corresponding to any other chemical, and you can see from the peak in the previous slide. Yeah, next please. Yes, coming to the XRD results, we wanted to analyze and further confirm from the XRD results there is no change in the chemical structure of the uh, fibers after treating with the FR, flame retardant finishes. We found the major peaks appeared in between 15 to 30 degree in the XRD graph, and we did this analysis of the crystal structure, and we confirmed that the cellulose A is present both the treated fiber and the untreated fiber. So basically, this 15 to 30 degrees centigrade, 30 degrees was the main peak was observed corresponding to the cellulose 1 structure of cotton fiber, and we did not find any significant peaks corresponding to polyester because our main component was more than 50% of cotton fiber in the blend. So we confirmed that there is no change to the chemical structure, because if there is a chemical change, and then there will be problem of durability or problem of the resistance of the cloth to flame over a long time. So we confirmed from FTIR and XRD results that there is no chemical change and only cellulose 1 structure is present from FTIR and XRD results. Yeah, next one please. Okay, so the technical aspect, also the company wanted to confirm that after washing, they did it later in 2015 or 2016, they wanted to confirm that after washing, there is no change in the flame retardancy. We subjected to 2 normal washing cycle using the industrial washing machine, and we again tested for flame retardancy. Mainly they wanted to check flame retardancy is not changing, and we found there was no change to the flame retardancy. Then next, our objective was to do the costing and see if the costing is economical for them, and if it is cheaper than the commercial product or it is expensive. So at that time, we took the market price, because when we buy the product, we buy in larger quantities. So we purchased 5 kilograms of citric acid with 13.5 Australian dollar, 5 kilogram of ammonium phosphate, $15, binder was 5.40, and wetting agent was 4.50. So total cost, it was 38.40 Australian dollar, and taking 100% wet pickup, so it will be coming close to 0.38 per kilogram of this fiber that we did the treatment. So we found that this product is cheaper than the commercial products, which I'm going to discuss in the next slide. So next slide, please. You can see here uh, basically the cost per kg of the fibrous mixture treatment. So with ammonium phosphate and citric acid, our cost was 38 cents per kilogram of this fibrous waste. When we compared with Citaflame, it was so expensive, and the company got half the price, less than half the price that they were supposed to pay for this commercial product. you can see both these commercial products, they are exceeding double the price of the chemicals that we formulated in the lab. The other thing is they don't need any certificate from the Environmental Protection Agency in Australia. And then from these, they were so happy, and then they started from the next month, they started the commercial manufacturing within like I think 2 or 3 weeks. They set everything to manufacture these waste in their plant and use this FR treated waste into their product line. So we recommended them how to design, and they designed with some commercial fabricators in Melbourne how to treat these flame retardant finishes into their fibrous waste, so which I'm going to discuss in the next slide. Next slide, please. We suggested the spraying method from 4 nozzles set at 90 degrees, and this was highly automated in terms of sensing the wetness of the fibrous waste. So we set 100% pickup by a humidity sensor. So the humidity sensor will sense that the wet pickup is 100%, and then again it will move forward. So basically what happens is some lot will come to the spraying nozzles, and it is sprayed for some seconds, about 20-30 seconds, and then the sensor will sense the moisture. When it is 100% wet pickup, then it will forward to the next lot. So with this, they were able to process about 2 tons every day. But unfortunately, the company stopped manufacturing in Australia from 2015 end or 2016 beginning, because they cannot survive with the cheap quality product coming from India. The labor cost was increasing day by day in Melbourne, and the cost of this entire property, because they have to pay rent. I think that company, they were hiring this building, and labor charges, utility charges, the electricity, the water charges. It was so expensive. So they closed this manufacturing. Although the company is selling the product now, so they um, stopped manufacturing after like 1.5 to 2 years of running this project. I was having the video. Unfortunately, I cannot get this video. It should have been better to show this video. So it was with Professor Rajiv, and he cannot find it. I requested him to give this commercial spraying equipment to show you. Yeah, so that is yeah, that was not available. It could have been better, like after Professor Goswami's video. I think I should have collected that video by any way. Okay, so just coming to the conclusion. So you can move to the next slide. As I said in the beginning, we want impact, and we achieve the impact by commercial manufacturing of the product for consumers in the mattress manufacturing segment in Australia. So our objective was to achieve flame retardancy and test that the product is suitable for their mattress. So we tested, and it was successfully implemented into the commercial product mattress manufacturing in Melbourne. There were some other project I worked in RMIT Melbourne, like the protective clothing. As I mentioned in the beginning, we do lots of real life tests. Like for example, when I worked in the ballistic testing, ballistic protective clothing, we had 2 different parts in this project, in the ballistic project. One was the 3D 3-dimensional textile for Australian Army when there was a fight in the Afghan sent some chamber. I did not understand. When I went to see how they test these bullets, it was really amazing. We stand in a viewing chamber, and it is completely bulletproof glass protected. So they covered with a bulletproof glass. They fire the bullets from the testing chamber. The people with the license to run these bullets, they can enter into the firing chamber. But we can watch it we can go into the viewing chamber, which is the glass chamber, and then we watch it. So we really saw what is happening, and they record everything in a slow speed video. So we watch how the bullet is going when it is firing to the 3D fabric, what is the mechanism of this penetration of this bullet into the fabric. That helps to understand the concept for developing a proper treatment, chemical or mechanical finish to the fabric, chemical finishes, or we use ceramic tiles to get this, and luckily we got the result what the Australian Defense Department got. The other project I worked was stab and spike. So the stab and spike concept we applied into different concept. One project came from the Victorian police, because many people they cannot keep gun in Australia. Like in the US, there are many gun firings, but the gun keeping rule in Australia is very strict. Therefore, people attack police by knives, and Australian police wanted to get stab protection by using the technology that we develop in RMIT. So we use the stab and spike protection, the aramid fabric, and it should be very lightweight. Before they use 4.5 kilograms of the vest inside the protective clothing inside their uniform, they told us to bring it down to 3 kilograms. And we achieved these results by using advanced fibers of aramid and Nomex, and doing some chemical treatment with boron carbide and some other chemicals. So we achieved the result, and we got the necessary protection by using the lightweight 3 kilograms. And we transport this technology to Victorian Police and the DMTC, which is Defense Material and Technology Center in Melbourne. They do many research to get protective clothing or advanced equipment for Australian Army. Okay, yeah, these are some of the project that I did in RMIT Melbourne. So basically, the difference is we look into more applicability of the knowledge into the practical field. Whether you name this protective clothing or uh, the flame retardancy, everything we want impact, which is very limited when I was in India. Although like we have got many facilities when I was in IIT Delhi, but use we have got the limited time, and many times there will be people like PhD students doing the test, so we have to book it in the in the record. I remember we have to go and book this instron with Biswal sir in the testing lab, and he will say, okay, this is booked for 3-4 days, and we have to go and see again. But here, like working from 7 to 9 or 10, we got more flexibility and multiple equipment. We have got these facilities in different campuses, so we can move to different campuses to do the testing. If one lab is busy, we had like 3 or 4 instron in the whole school. We can move from one to the other. Yeah, so that was the advantage of doing research in a multidisciplinary research environment. Okay, yeah, can you please move to the next one? I think I already concluded. Yeah, so yeah, this is all about my presentation. It's already 1 hour when I started. I think I'll stop now. Thanks everyone for your attention. So any questions, please? Over to you, Jamini ma'am.
Yes, sir. Am I audible, sir?
Yes.
Thank you, sir. Thanks a lot for very comprehensive presentation. We all at TIT, We appreciate all the research work that you have been putting in with all the resources available at Remit Vietnam. But as of our previous memories with you, we all remember you as a very hard-working and dedicated colleague of ours. So, and we are really thankful that you joined us. You gave us time, and you um managed to take out time for us. So, thank you. Thanks a lot, sir. So now it's over to you, Guru Pratap. So, Guru Pratap will proceed further.
Thank you so much, ma'am. I'm audible.
Yes, yes, you are very much audible.
Okay, thank you, ma'am. To improve the golden moment of opportunity and catch the good that is in our reach is the art of life. A very warm good afternoon to the galaxy of intellectuals, keynote speakers, professors, participants, and coordinators. It's a matter of immense pride to speak before all of you. On behalf of department, I am delighted to offer a gracious welcome to all of you to the valedictory session of International E-Conference Recent Trends in Textiles 2020. The function of prayer is not to influence God, but rather to change the nature of the one who prays. With this, I request technical team to please start the Saraswati Vandana.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतं शङ्करं प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा
Thank you so much, technical team. The fragrance of flowers spread only in the direction of wind, but goodness of a person spreads in all direction. With this beautiful quote, I would request Professor Dr. Parikshit Goswami sir to please give a small message to all and talk about the conference for a few minutes. Over to you, Parikshit Goswami sir, please.
Uh, Guru Pratap, you should know that it's very difficult to follow you. I have never heard somebody speak so nicely like you. You're blessed by the God.
Thank you so much, sir.
Right. Uh, it was such a well organized conference that I want to thank everybody for arranging it. But most importantly, the topic that you have selected can't be more contemporary than what you have done. You have tried to bring different flavors of the textile industry uh, holistically into one dimension, so that every aspect of that can be discussed and critically analyzed. My suggestion will be, on back of this conference, to create a platform where we can continue the dialogue, we can cross fertilize our knowledge, and we can all learn. If we can make that happen, and I'll really honestly hope that it happens, so that we can bring policymakers, we can bring everybody together and nurture fundamental as well as applied research. You have already put the seeds in, so I hope this will continue. And thank you very much for giving me a part, giving me a role in this excellent initiative. It's absolutely a privilege to talk in front of everybody, and thank you so much.
Thank you so much, sir, for your
Thank you,
influential
Parikshit, sir.
message
Thank you.
and your
Thank you.
suggestion. Thank you so much, sir.
Just to add, if I can play a role in that future consortium, I'll be more than happy for my team and myself to play a role there. Thank you.
Yes, sir, sir, you are always welcome, and it would be an honor for us all.
The honor will be for my team. Thank you.
Sir, it was your generosity to spare time for you, and that's all I can say. Okay, you can proceed.
Thank you, ma'am. Thank you, sir. Nothing great will be achieved without great men, and men are only great if they are determined to do so. With this quote, I would request Dr. Raj Kishore Nayak sir to please give a small message and talk about the conference for a few minutes. Over to you, Raj Kishore sir, please.
Thanks, Gurpreet. So your talk is so nice, as Professor Goswami told. So
Thank you.
nice, everything is wordings particularly, and the way you are saying, so impressive. Okay, I would like to thank all of these TIT members, including Ken Chatterjee sir, Jamini Janji ma'am, and yourself, all the organizing committee and technical team, to organize such a nice conference in these COVID situations, which brought the people not only from India but also from the other countries, including Professor Goswami and myself, to this platform. So I think in the future we should have more sort of activities like this, which will be sharing the knowledge in the recent field, like Professor Kotari said, our respected Kotari sir said yesterday, the future of textiles is in the nanomaterial, medical textiles, circular economy, protective clothing, nano finishing, artificial neural network or ANN, human ecology, which is the thermal comfort aspects, sustainability. So I think in this 2 days conference, many of these aspects, as mentioned by respected Kothari sir, has been covered. And this will give a platform, a guideline to the researchers who are already established or who are in the early career to plan for the future. Like when I was in Melbourne, so attending the conference gives a lot of inspiration and knowledge to change, to make your way in the field of research, and which can lead to the success in the academic research. There were numerous keynote speakers, including Kotari sir, then Kushal Sen sir, and today we got Dipti Madam and Professor Goswami. So very good platform to have their experience and technical knowledge. So this will give me as well, including all the participants, new knowledge to formulate, to find ways for the future research. And because of this COVID-19, so many of us are facing challenges working from home, or there are job cuts. So I would like to pray, or maybe we should all pray together to the Almighty to overcome this impeding economic impact on the fashion and textile industries, and we should be ready in 2021 to lead the way in the research in academics like we were doing in the 2019. So thanks everyone to take part in this conference. Over to you, Gurpreet.
Thank you, sir. Thank you so much, sir, for enlightening words. Now, I would request the interested participants, those who want to share their valuable feedback right now. So, in the first, we'll have J. Ananda Kumar, sir. I would request you to please share your valuable feedback of the International E-Conference 2020.
So, hello, good evening to all respected dignitaries and team members of TIT&S Bhiwani and all the technical people and participants who were become part of this international conference. And it gives me immense pleasure to give my valuable feedback in front of this August gathering. And I do remember the day when the conference was started, I compliment Yamini madam because she was constantly in touch with all of the participants through media and mail. And we used to get frequently, our inbox get filled with Yamini madam's repeated mails. So it got me an enthusiasm to participate in this conference. And even I took initially I was hesitant, and later I prepared a paper, and the way it was proceeding, and they have developed a very good website. In fact, I compliment that also, because it gives us to track our record and progress, everything. It was well planned, and I congratulate the entire team for making this conference. And even I have presented a paper, and I got a very good valuable feedback from Professor IT, Professor Kushal Sen. So that gives me a lot of insight about the future research scope. And every deliberation was very much useful. And I congratulate, because since it was parallel session, I could attend a few, and even I got a lot of inputs from that. And last but not least, I was after listening Goswami sir's speech. In fact, it gives me a boost to think in commercial terms, and also how to make patents, because those are all the real success for any researchers. So I'm really happy, and I congratulate all the team members behind this conference, and the team members of Yamini Madam for making this conference a grand success. I'm really, once again, I congratulate you all. Thank you all.
Thank you so much, Jay Ananda Kumar sir, for your valuable feedback. Now, I would like to read some of the chat because participants are writing in the chat to the team. So, first it's Janme Hada. Congratulations to TIT&S team. You all have done hard work to complete good conference. Dr. Yamini ma'am, thank you very much for your support and coordination. I really enjoy the session and presenter. Tripti Doka, yes, a very well organized conference, especially the technical assistance. Dr. Pratima Goyal, million congratulations to TIT team for organizing such a wonderful conference. Janvi Premani, thank you so much AICT team. It was an amazing to be a part of this conference. Hope to attend many such events. So thank you all the participants, those who are writing in the chat box right now. With this, I would request the head of department of fashion and apparel engineering department at the Technological Institute of Textile Sciences Bhiwani, Professor Dr. K.N. Chatterjee sir, to give the formal concluding remarks for this International E-Conference, Recent Trends in Textile 2020. Over to you, Chatterjee sir. Please.
Thank you, Gopal. Already we have seen the many remarks on the chat box. So, ladies and gentlemen, very good afternoon and warm welcome to the valedictory session of the AICT sponsored E-International Conference 2020 on recent trends in textiles. We are really fortunate to have such eminent personalities from academic field, from NIT, IIT Delhi, RMIT, University of Huddersfield, and we have enriched our knowledge through their lucid and attractive presentations and addresses. We are really honored by their presence. I am sure that all will appreciate their presentations. We have also witnessed wonderful and colorful presentations throughout the conference on recent trends in textiles, be it oral presentation or poster presentation. In fact, whatever Dr. Nayak said, Rajkumar Nayak, that Dr. Kothari sir, in his initial keynote address, explained the various innovations, the areas, the future trends, and we have almost covered every aspect of the right from the fiber, fabrics, processing, chemical processing, garment, fashion, this sustainability, waste management. Now today, even we are fortunate enough to have the excellent presentation from Parikshit Goswami and as well as Rajkishore Nayak that how this waste management or sustainability can be utilized and in a profitable manner. In fact, we do research work, but that is not a the calculated in the cost effective manner. So we should start with. Now the conference was started on 18th September at 9:30 a.m. by Ma Saraswati Bandana, followed by welcome address by our OD Director Professor Dr. G.K. Tyagi, while welcoming all the dignitaries like keynote speakers Dr. V.K. Kothari, Dr. Kushal Sen, as well as all the delegates and participants of the conference. He also stressed the need of such conferences for highlighting the recent trends in textiles and apparels like technical textile, medical textile, and so on. He also made encouraging remarks of Dr. Jamini Ghanji, coordinator of the conference, for taking such initiative for conducting such a wonderful conference, which is need of the hour. I am sure Dr. Jamini Ghanji will continue with these activities and will find in near future many of such events. So Dr. Jamini Ghanji, while toning the conference, explained the details of the conference, shared the information about what to do and what not to do and how to do about the presentation. She also briefed about the number of participants and their work area. Dr. V.K. Kothari, Emeritus Professor IIT Delhi, while delivering the first keynote address of 18th September 2020 during the inaugural function on importance of innovation and prosperity and growth of textile and clothing industry, he discussed in depth about the innovations in fibers, yarn, chemical processing, non-wovens, technical textile, and so on. His thought-provoking address was quite beneficial to all the participants, and it will go a long way for in doing research work in those areas. Dr. Kushal Sen, Professor IIT Delhi, while delivering the second keynote address during the inaugural function on online education challenges and opportunities. He elaborated in details about the online education, which is the buzzword today and need of the hour during the COVID-19 session. All of us nowadays experiencing the situation like online classes, whether it is a student, whether it is a faculty members, and he dealt with the various tools and activities of online systems as well as various websites that will be useful for the faculty members, researchers, and I think everybody now they witness the various type of systems like NPTEL, NOC, MOOC courses, and how to evaluate the evaluating methods. So how to evaluate the papers, how to conduct the exams, and how to conduct the practical classes even, practical classes as well as project. Due to huge number of participants in the conference, the paper presentations and poster presentation were done in 3 virtual rooms like VRA, VRB, and VRC. In the first technical session, one of 18 September 2020, which was started from 11:30 a.m. onwards in VRA, the theme was clothing comfort, protective textile and sportswear, and Dr. V.K. Kothari chaired the session and Dr. Jamini Gandhi was the moderator. In this session, 10 to 20 presenters were there. Many impressive research works were covered in this session, like transmittance properties of textiles in view of thermophysiological clothing comfort, liquid and vapor moisture management in high active sportswear, healthcare, professional protective wear, mask for COVID-19, NBC protective clothing system, physiological and psychological status, study on relationships between objective and subjective evaluation of drapability, is of sportswear and badminton players, athleisure, acquisition of a new category, a review on trivial alteration can make fabric UV protective. So I thank all the the presenters. They have done excellent job. They have actually maintained the time also, and they gave the good research work. In the first technical session of 18 September 2020 in VRB, theme was technical textiles and medical textiles. Dr. Seli Khanna chaired the session. In this session, 12 presenters were there. Many important papers were delivered by the presenters like fabrication and properties, evaluation of banana-based hybrid composites, then investigation of different oven designs of 3D structures, particle board of made from the sugarcane baggage for furniture, reusable face masks for the knitted fabric with chemical treatment, effect of rainfall intensity and slope angle on erosion control, percentage of geometries, potential use of jute, wire and other minor fibers for agrotech, sustainable clothing using bio-nano emulsion for healthcare applications, design and development of surgical gown using red seaweed extract for hygiene textiles, then characteristics and non-woven component of textile-based compression intervention, tissue engineering, the current scenario and innovations, then nanofiber materials as barnwood dressing, and then a study on the use and side effects of compression bandages. In the second session, technical session, which was started from 2 p.m. Onwards in virtual conference number A, the theme was innovative approaches in textile processing. Dr. Kushal Sen chaired the session and Dr. Jamini Janji was the moderator. In this session, 12 presentations were there. And in this case, the various topics were dealt by the dyeing of silk fabric with soaked vulgaris, red kidney bean, then dyeing of cotton fabric with red soil for home textile application, then micro encapsulation, the future of textile finishes, a study on the effect of moisture fabric structure, dye class on the color of cotton fabrics, and eco-friendly dyeing of silk fabric by Cedar Cordicular natural dye, review study of the denim jeans on chemical process parameters, functional finishing on airy silk and its union fabrics by hydrophobicity, then optimization of antibacterial and comfort characterization of woven fabrics, study on coatings for textile substrate, optimization of alkali treatment of jute yarn using box bank and design, application of titanium dioxide nanoparticle to incorporate self-cleaning on polyester fabric, then functional finishing of the man's corporate ensembles using innate jute fabrics. So that was the very good session, technical session 2. Many learned speakers were there. In the second technical session 2 in DRB, the theme was sustainable and waste management aspects of textile and fashion supply chain. Dr. K. N. Chatterjee chaired the session, and in this session, 14 presenters were there, and they have started with the upcycling and emerging textile waste management strategy for the fashion industry, then sustainable supply chain management in fast fashion driven economy, transformation of fashion brands, a step to sustainability, evaluation of consumer perception and purchase intention of recycled fashion products, upcycling, a roadmap towards sustainable fashion, mapping the acceptance of Indian footwear industry for vocal for local, a sustainable paradigm, sustainability issues of ring, rotor and air jet spinning system, sustainable development in textile dyeing and printing, then eco printing, a sustainable method of textile printing, Lake's mediator system, roll of coumarin based dyes in textile industry, screening and optimization of natural dye from fungi, sustainable dyeing of silk by natural extracts, then decolorization of textile dye equipment using cost-effective techniques. In the third technical session 3, which was started from 4:30 p.m. onwards in VRA, the theme was innovative approaches in tradition textiles, retailing and fashion promotion. Dr. Jamini Janji chaired the session. In this session, the 14 presenters were there, and they are very good technical presentation like upcycling of sustainable textile using natural waste resources and traditional design, fusing traditional textiles, sustaining and inventing traditional textiles, draping traditional Indian fabric with a modern touch, a novel look, unraveling the weaver scenario of Indian handloom sector, a case study, then traditional arts and crafts, then you have got the innovative of Eri silk in Meghalaya, creation of fashion apparels by adaptation of Karnataka tribal art, dyeing of chicken curry fabric with agile mementos, lean productive strategy for apparel, analysis of needle thread tension profile in lock stitch seam, traditional textile in home fashion, then which types of clothes your wardrobe is asking for, the collaborative role of buyers and merchandiser in fashion retail industry. In third session two, third session three, which was started from 4:30 p.m. VRB, the theme was computer intervention and AI in textile and fashion. Dr. Jyoti Chaudhary chaired the session, and in this session, the 12 presenters were there. Very good presentation by Dr. Pradeep Joshi, the Education 4.0, Fashion Education in Era of Artificial Intelligence. Then Artificial Intelligence, a revolutionary factor in e-commerce. AI technologies, a key to unlock the door of omni-channel capabilities. Computer intervention in textile and fashion. Study on optimistic need of artificial intelligence in fashion and retail industry. Artificial intelligence design suggestion in for apparel retail counter, then the impact of artificial intelligence in garment and apparel industry, electronic textile and overview, and intelligent textiles and application and overview. Then we have got in the first technical session, that is the technical session 4 of 19th September 2020, which was started from 9:15 onwards. In VRA, the theme was Advances and Innovations in Fiber, Polymers, Yarn and Fabric Production. Dr. Binay Midda chaired the session and Dr. Jamini Jhanji was the moderator. In this session, 8 presenters were there. One is a Dr. Supriyo, cellulose-based aerogels, their specialty and application, very good paper. Then application of nanotechnology, Dr. Chetna Meena, that was also very good by layer, deposition technique to improve the functionality of textile. Then Meenakshi Tamta, innovative application of pineapple leaf fiber in textile and other fields. Amal Chaudhary, Dr. Amal Chaudhary, the fiber spinning technologies, conventional to nanofibers, waterproof breathable fabrics, new trends in non-woven textiles, study of impact of air consumption on air jet machine. That was a good, very good presentation. And then noise pollution in shuttle loops. There are other papers also there. In the second paper, in the second technical session of there was a Dr. Roshni Goel. That session theme was the sustainable textile procurement, chaired by the Dr. Roshni Goel. There is a paper as the recycling and approach towards the sustainability, innovative sustainable materials revolutioning the textile industry, new sustainable fibers and their application in textile, need of post-consumer textile waste management via circular economy, then opportunities for sustainable nettle and wool spinning at Uttarakhand, then in bioplastic, a new generation textile material. Here are biomaterial in future of the textile industry, effluent treatment in textile industry, study on relationship between knowledge factors increasing. There is a 9 presenter was there. Then we have got very good session about the there's a invited talk by Dr. Dipti Gupta from IIT Delhi. Our topic was the future direction in textile finishing, and she did a very good job about delivering the new techniques. And I am saying she elaborated many recent innovation in textile chemical processing. And while delivering her keynote address, she delivered a lot of activities going on and what is the future strategies in the near future. And it is my firm belief that many researchers will start their research work in these areas. Then in the technical session, that is the theme was the innovation and advances in fashion, garment designing and manufacturing, chaired by Dr. Dipti Gupta and moderated by the Dr. Jamini Jhanji. And in this session, the 8 presenters were there. The presenting was the innovative and sustainable design development for denim fabric using laser techniques, tie and dye and manual whiskering. Then exploring methods of integrating conductive threads for wearable technology for smart clothing in textile and fashion, young consumer perception about apparel size and fit, the designing of clothing for little people, functionality and performing enhancement of apparel by integration of smart fabrics, the creation of tote bags for college going girls, factor identification and validation for skill training for apparel sector. And I think there are many more participants were there under the chairmanship of Jamini Janji. Then there are poster presentations. There is also two sessions, one chaired by Dr. K. Chatterjee and another is Dr. Amal Chaudhary. Many good posters are presented by Jeba and team, the softening of jute by enzyme combination, then dyeing of cotton silk using vegetable kitchen waste, innovative approach in the use of traditional angi of Haryana, khadi, the fabric of freedom, Arogya Pata, a natural protection, very good poster by Saloni Jain. Then motifs and designs used for making traditional Punjabi basketry handicraft as well as physical properties of extracted fibers from plant materials, asoka and other material. Diversification of hosiery production towards blended needs, paper pattern, zero waste fashion design practices, innovative jewelry, anthropometry, garment sizing and fit for differently able people, virtual trial room, sustainable fashion opportunities in India, polyacrylonitrile zinc oxide, nanotechnology, use of coffee grounds in textile processing. So you can find that the whole gamut of the textile and apparel industry is being covered in this area. And last but not the least, the today's final technical session, Dr. Parikshit Goswami, Professor, University of Huddersfield, while delivering his excellent presentation during the first keynote address, during the final technical session of innovation and trends and textiles. And in fact, he also dealt with the sustainability and medical textile healthcare industries. He delivered in depth about the sustainability and practical approach of biodegradable material in medical, textile, and healthcare activities, and so on. And I am sure his thought-provoking presentation will be quite useful to all the speakers, delegates, and participants. And thank you, Dr. Goswami. And I think in near future also you should start delivering lectures not only to our students but also our faculty members. Besides, your this type of conferences. Dr. Rajkishan Nayak, Senior Lecturer, RMIT University, while delivering the second keynote address on sustainable reuse of fashion waste as flame retardant mattress filling with eco-friendly chemicals. He elaborated in details about the uses of waste materials, which is the need of the hours for the whole society or human kind. I am confident that after going through his impressive presentations, many researchers will start working in this direction. So it has been our pleasure to organize such a useful international conference at TIT&S Bhiwani. The participants are very enthusiastic. I'm thankful to all the participants for attending the conference. We have been fortunate to have some of the eminent persons from academic in the area of textile and apparel sector. I am sure that the participants must have benefited by attending this conference. I'm very thankful to AICT, sponsors of the conference. Without their generous financial support, it would not be possible to organize this conference. So validation will also started with the Maha Saraswati Bandana. So thank you all. I'm sure Jamini ma'am will continue these activities in near future. Thanks a lot.
Thank you so much, sir, for your precious conclusion and for your kind words. Now, I would like to invite the most hardworking person for this international e-conference. Without her efforts, this conference was not going to be this much smooth. With this, I request Dr. Yamini Jhanji ma'am, coordinator of this conference, to please present a vote of thanks for everyone. Over to you, ma'am.
Thank you, Guru Pratap, but I need to correct you here. I'm not the only one who is hardworking here. So you all are in that league. So here goes my vote of thanks. Kindly bear with me if it becomes a bit lengthy. So I welcome all the dignitaries, delegates, presenters, and researchers once again. I have been assigned this very difficult, I must say, yet the most crucial part of the conference, that is extending vote of thanks. Difficult because a mere 1.5 page thank you note can't express my gratitude and appreciation for each one involved in making the program happen. Crucial, of course, because we need to acknowledge each bit of effort everyone has put in and has been head over heels, turning no stone unturned, leaving no stone unturned, shaping the program and giving it such a grand culmination. My sincerest thanks to AICTE for sponsoring the international conference and enabling us to go ahead in an uninterrupted manner. Thanks are due to Professor Dr. K.N. Chatterjee, Director TI. Thanks are due to Professor Dr. G.K. Tyagi, Director TIT&S Bhiwani, and Professor Dr. K.N. Chatterjee, Head of the Department Fashion and Apparel Engineering, who has always encouraged and motivated the faculty to pursue with such career advancement programs. I am thankful to Chief Administrative Officer Mr. Pramod, Account Sec Mr. Aishwarya, and their entire team to facilitate the conference team in every possible way. Thanks are also due to all the departmental heads, faculties, colleagues, my friends, especially Dr. Amandeep Kaur and Dr. Shelly Khanna, who encouraged me and stood by the entire team in thick and thin. My special thanks to all the national and international dignitaries, namely Professor Dr. V.K. Kothari, Professor Kushal Sen, Professor Dipti Gupta from IIT Delhi, Professor Parikshit Goswami from University of Huddersfield, Dr. Raj Kishore Nayak from Remote University, and last but not the least, Professor Vinay Midha from NIT Jalandhar. These dignitaries have been kind enough not just to accept our invitation to grace the occasion as keynote speakers and for chairing the sessions, but always have been so supportive and prompt in replying to my long messages and mails and bearing with all the technical glitches. Me, along with my entire team, is thankful to all the dignitaries who chaired and handled the sessions effectively. Professor Dr. V.K. Kothari, Professor Kushal Sen, Professor Dipti Gupta, Professor Vinay Midha, Professor Dr. K.N. Chatterjee, Dr. Shelly Khanna, Dr. Ashwini Goyal, Dr. Jyoti Chaudhary, and Dr. Amal Chaudhary need a special mention for chairing the technical sessions. We talk of virtual meeting, virtual conferences, and of course, you all would appreciate that a strong, dedicated technical team is the backbone and an indispensable part of an online conference. My sincerest thanks and the biggest thanks, of course, to our technical support partners, Spikeage, Miss Poonam Panchal, I can see her here. Miss Poonam Panchal, MD Spikeage, and her entire team, namely Shikha, Rohan, Pooja, and Hardik, who have been cooperating day in and day out, considering it to be their own conference. Special thanks to Poonam ma'am and Shikha. I am also sorry to you both, whom I have bothered even on weekends and even during the odd hours of the day, but they were so supportive and always at my disposal. Thank you, ma'am. The technical team of our college has been equally instrumental in providing all the technical support and logistics. Mr. Surinder Singh, along with his entire team, Mr. Vinod Kidoriwal, Mr. Sanjay Sharma, and Mr. Sanjay Singhal were always at our disposal, considering our novice approach to technology. Thanks are also due to press and media team, Mr. Kamal Sardana and Mr. Satish Khatak for elaborate print media coverage of the event. My sincerest thanks are due to the unprecedented number of participants. When I started, I was not very sure that we'll get that much number of participants, but we had this much good number of participation with nearly 150 participants in totality, being presenters, co-authors, and attendees. We had participants from different nooks and corners of countries, from different institutes of national and international repute, who presented good, novel research design oriented projects. It's because of your proactive participation that program could be conducted smoothly and I suppose successfully also. Last but not the least, I owe a very, very big thanks it can be considered as a synonym with 3 cheers for the team of our dedicated students. So I can see some of the students here, but not all of them. So by now the participants must be knowing our students team. So Ashish, Shubham, Gurpratap, Preeti, Swati, Shashank, Yatika, Komal, Achla, Ankit and Vishal. So I'm really thankful to you all who had burnt midnight oils balancing their studies with conference work and always supporting and standing beside me rock strong. Thank you, my beloved students. It would not have been possible without you all besides me. And lastly, I would also like to thank my husband, who has been so accommodating and surviving on Maggie, considering that his wife has been coordinating this conference. So eventually, I stop here and thank each and everyone explicitly or implicitly involved in the conference work. And my sincerest apologies if I missed out any of the name, but I wholeheartedly thank you. Thank you everyone for all your support, for all your cooperation. It would not have been possible without the support of you all. Thank you.
Thank you so much, ma'am, for your kind words, and thank you so much for guiding us on time. So now, it was indeed a pleasure to have such a large number of audience in form of dignitaries, delegates, academicians, and researchers joining us. We wish to take it forward and stay connected as long as we can. So, on this note, we sign off, leaving you all a song dedicated to all of you by Vishal Sharma, student of the Technological Institute of Textile and Sciences, Bhiwani. Over to Vishal. Vishal, you may start.
Am I audible to everyone?
Yes, you are audible.
Okay. Good afternoon, everyone.
Good afternoon, beta. Thanks for joining us.
Thank you, ma'am. Oh, Rabba. Oh, Rabba. Oh, Rabba. कोई मेरे दिल दा हाल न जाने ओ रब्बा कोई मेरे दिल दा हाल न जाने ओ रब्बा रो रो के थक गए नैन न माने ओ रब्बा कोई मेरे दिल दा हाल न जाने हो रब्बा जेड़े तुर जांदे पिछा मुड़ के नहीं थकदे जेड़े तुर जांदे पिछा मुड़ के नहीं तकदे होया की कसूर सातो एवें ते नी दस दे होया की कसूर सातो एवें ते नी दस दे किथे जाके लाए उन्हें अपने ठिकाने ओ रब्बा कोई मेरे दिल दा हाल न जाने हो रब्बा रो रो के थक गए नैन न माने ओ रब्बा कोई मेरे दिल दा हाल न जाने हो रब्बा। बे तुझे देख देख सोना, तुझे देख कर है जगना, मैंने ये जिंदगानी संग तेरे बितानी, तुझ पे बरसी है मेरी जान हाय। जिया धड़क धड़क, जिया धड़क धड़क, जिया धड़क धड़क जाए। जिया धड़क धड़क, जिया धड़क धड़क, जिया धड़क धड़क जाए। कब से है दिल में मेरे अरमा कहीं न कहे हो, कब से है दिल में मेरे अरमा कहीं न कहे। इनको तो सुन ले आजा, चाहत के रंग चढ़ा जा। इनको तो सुन ले आजा, चाहत के रंग चढ़ा जा। कहना कभी तो मेरा मान हाय। जिया धड़क धड़क, जिया धड़क धड़क, जिया धड़क धड़क जाए। तेरे संग खेली होली, तेरे संग की दिवाली, तेरे अंगना की छाया, तेरे संग सावन आया। तेरे ले तू चाहे नजरे चाहे चुरा ले, लौट के तू आएगा रे शर्त लगा ले। तीजा तेरा रंग था मैं तो, तीजा तेरा रंग था मैं तो, जिया तेरे ढंग से मैं तो। तू ही था मौला तू ही मौला मेरे, ले ले मेरी जान। मौला मेरे ले ले मेरी जान। तुमको भी है खबर, मुझको भी है पता, हो रहा है जुदा दोनों का रास्ता। दूर जाके भी मुझसे तुम मेरी यादों में रहना, कभी अलविदा ना कहना, कभी अलविदा ना कहना, कभी अलविदा ना कहना, कभी अलविदा ना कहना। थैंक यू सो मच।
Okay, Gurprata, I
Thank
think
you so much, Vishal, for this song. You have a God-gifted voice. The chat box is full with your name, so you can check the chat box also. Now I would request K.N. Chatterjee sir. Sir, participants are requesting to listen your song. So I would request you to please.
गुरुप्रसाद तुम उनको ही बोलो जो पार्टिसिपेंट से को सॉन्ग का गड़ेगा, और परीक्षित सर है, नायक सर है, इनको ही बोलो तो दो शब्द ये लोग भी सुनाएंगे, ठीक है?
Sure,
Okay.
sir. But sir,
चलो मैं एक
I
सुना
think
लेता
we
हूँ।
should start with you, sir.
ओके ओके होगा। चल के तुझे मैं लेके चलूं एक ऐसे गगन के तले, जहाँ गम भी ना हो, आंसू भी ना हो, बस प्यार ही प्यार पले। एक ऐसे गगन के तले, चल के तुझे मैं लेके चलूं एक ऐसे गगन के तले, जहाँ गम भी ना हो, आंसू भी ना हो, बस प्यार ही प्यार पले। एक ऐसे गगन के तले, जहाँ दूर नजर दोहराए, आजाद गगन लहराए, जहाँ दूर नजर दोहराए, आजाद गगन लहराए, जहाँ रंग बिरंगे पंछी आशा का संदेशा लाए, जहाँ रंग बिरंगे पंछी आशा का संदेशा लाए। कहीं धूप खिले, कहीं छाँव मिले, लंबी सी डगर न खले, जहाँ गम भी न हो, आंसू भी न हो, बस प्यार ही प्यार पले। एक ऐसे गगन के तले, एक ऐसे गगन के तले। थैंक यू भाई, थैंक यू। बाकी लोगों को बोलो कौन है लाइन में, कौन है
सर? अभी लाइन में है पूनम मैम।
पूनम मैम, सुनाओ जरा।
She is the MD of Spikage and the backbone of our technical team.
Very
So
good.
we would like to see that apart from technical aspect, how managed she wants to sing for us.
Now I'll request participants' point of view also.
Yes, sir.
Any participant would like to?
Yes, sir. After Poonam ma'am.
Specifically, Parikshit
Bhiwani
sir.
ma'am, thank you so much. Thank you so much. And it is really a wonderful experience we all are having together on this
Same here,
online
ma'am.
platform. And I would take after one participant, please.
Okay. You need to rehearse.
I will sing, definitely I will sing. Just give me 1 minute.
Okay, okay.
Okay, ma'am. As Parikshit Goswami sir has left the message in the chat box that
Yes,
he have
yes,
to
I
go.
saw. Yes.
तो चलो और एक छोटा सा सुन लो।
Yes, sir. Sure, sir.
राही मत वाले तू छेड़ के बार मन खसीदार, जाने कब चोरी चोरी आई है बाहर, छेड़ मन कसीदार। राही मत वाले देख देख चकोरी का मन हुआ चंचल, चंदा के मुखड़े पे बदरी का अंचल, देख देख चकोरी का अंचल। ओहो सॉरी मिस कर गया। चलो आप तो उसको सुनाओ पूनम मैम को।
Okay, sir, can I sing Punjabi song?
Okay, yes, why not?
Yes, ma'am. That would be the best part if you sing Punjabi song. Me being a Punjabi, of course.
Okay. There is a very old songs. There is a series of songs that I like a lot. That is sung by Surinder Kaur, folk Punjabi songs. I love all the series of that cassette. That is one from that one. चिट्टा कुक्कड़ बनेरे ते, चिट्टा कुक्कड़ बनेरे ते, काशनी दुपट्टे वालिए मुंडा सदके तेरे ते, काशनी दुपट्टे वालिए मुंडा सदके तेरे ते, पिपली दिया छावानी पिपली दिया छावानी अपे हथ डोली तोर के मापे करने दुआवानी अपे हथ के मापे करने दुआवानी कुंडा थैंक यू सो मच इतना ही याद है मुझे
Very nice, ma'am. Very nice. Such a lovely voice you have got.
वेरी गुड, वेरी
Thank you.
गुड। हाँ, इसको
Thank
जारी
you.
रखना, प्रैक्टिस करो घर में।
थैंक यू सो मच सर आज इतने टाइम के बाद ना आई गोट दैट चांस टू sing and I'm really enjoying this session and that must
That's
keep
true.
going on.
That's true. Any participant? Gupratap, request करो।
I request all the participants.
ज्योति चौधरी मैम।
Hello.
Views or you sing a song.
ज्योति
Okay,
चौधरी मैम,
Vishaka
Srini मैम, विशाखा,
Yeah,
विशाखा
hello.
मैम।
I would like to just sing a song, one of my favorites.
Sure, ma'am,
Yes,
sure.
ma'am. Go
Sure,
ahead,
sure.
please. Yes.
जाइए आप कहाँ जाएंगे, ये नजर लौट के फिर आएगी, ये नजर लौट के फिर आएगी। दूर तक आपके पीछे पीछे मेरी आवाज चली आएगी। जाइए आप कहाँ जाएंगे, ये नजर लौट के फिर आएगी। This is for all of you, even if I am far away in Mumbai, this virtual thing has brought us together. I'm so happy that I've
Very
been
nice,
able to
ma'am.
participate.
Very
Very
nice.
good, very good. Well
Very
done.
nice.
बहुत अच्छा।
Your voice is equally beautiful as your thoughts. Very nice, ma'am.
Thank
So,
you
sir,
so much to the entire team.
thank you. Pleasure is all ours, ma'am. Thank you. So, sir, can we end on this note?
Yes, yes,
Okay, good Pratap.
absolutely.
Okay, ma'am. Okay, I request all the participants and my dear teachers. Um, I would like to say a big thank you to all the participants and my dear teachers for maintaining in this session from starting till now. And I would request technical team to please switch off this link. And I would request all the teachers and I pay a big gratitude to them for doing such a great conference. Special thanks to Yamini ma'am, Chatterjee sir, Ashwini Goyal sir, Poonam Panchal ma'am, and every teacher who is present right now, Jyoti Chaudhary ma'am. So with this note, we would like to end this meeting. So thank you everyone.
Okay, thank you. And I wish we'll be in touch very soon. We'll come up with many